This is a video going through my WWISE integration and how I have changed the audio for this silent project. So firstly, I'm going to start with the wind I implemented. I'd created a custom blueprint that gathered the distance between the player and a place actor in the world, and this number or value was changed into a float, and then this float was plugged into a blend container within WWISE. The vector value would affect the RTPC value. Another way I'd implemented wind is by placing actors around specific parts of the world. So for instance, in this part, there's a distant wind in the background as the camera zooms out, and it gives this feeling of space. And I end up reusing this way of implementing audio throughout the level. The rest of the ambience is done by placing actors in specific areas with simple events calling for each. So for the electric, fans, radar, and the cogs around the level. I had also added in perspective changes for these cog sounds. So when the player was stood above or next to the cogs, you'd be hearing the high end and the mid end, whereas if you was to stand below the cogs, you'd hear the low bass end of the sounds. Another way I'd implemented audio is by attaching AK components to the viewports and actual blueprints themselves. This means you can view your attenuation spheres and they stay attached to the moving objects. If the player were to fall off the map, it would trigger a collision box and play a short sound indicating that they had fallen off. Finally, I had added AK reverb volumes to the domes in the level, and you can send what sounds you want reverberated through this to this bus by using the game-defined auxiliary sentence. So this next part I want to talk about the footstep system. I had created a blueprint that would send a line trace out the foot of the robot, and it would grab the material instance that was attached to the surface underneath it. I'd create custom materials for each of these surfaces around the level and then attach them manually. These added materials are linked to a switch group on WWISE, and when called, they play the correct containers containing the different material sounds for each footstep. I'd also added braking and debris sounds to the destructible platforms. The footsteps on top of the domes are also reverberated, creating a cool effect. There are vocalizations for the enemies around the map. These are cartoon-like, and when the enemies are stood on, they create a death sound. When the player gets hit, it creates a damage sound, and this sound is the same for when the player touches electricity. There are multiple layers to the movements. In the animation blueprint and the animation timeline, they are added onto notified tracks. The servos and mechanical movements are state-based and are constantly playing and can be called upon within the ABP, as you'll see here. In WWISE, the states are set up so that it will transition from off to on, and the volume will change like so, and it will give a seamless transition between the two. Here's an example of the jetpack. The box mechanics are also state-based. Whenever the player picks the box up, it will play a short sound effect, and whenever the box collides with something, it will play a collision. The button, platform and jump pad have design sounds that are all attached within their custom blueprints. There are also custom sounds for the UI boxes and objective buttons, and chirps of the bot. There are 4 objective buttons placed around the map. When pressed, these all play a sequence container. The sequence container has a musical progression that gets built upon each time. And finally, once all 4 buttons are pressed, it opens up a portal where the player can end the game. So lastly, the coins are affected by RTPC. There's a timeline node within the blueprint of the collection that gathers the time between picking up and spawning the coins. Both of these are represented on timeline graphs, and the values are then inputted into Wwise and given the pitch manipulation. And to end, I had to change the audio listeners to the bot's head, as on the 2D part of the level you cannot hear the audio as it's attached to the camera.